Maybe I don't have the flex out. I don't know. Oh, here it is. Peter, the updated one is flexible algorithm, right? Yeah. I see. Yeah.
It's so weird to not see ISIs there.
Okay.
Test. Yep. Oh yeah, it works. Do you want blue sheets?
Oh, yeah, I already got the blue sheets.
Oh,
wrong.
you did.
Yeah.
Awesome.
Mhm.
You're on top of things.
Y'all come in and have a chair.
Make sure you sign those blue sheets. Vote early, vote often. We'll get a bigger room.
Yeah.
What did you say? Come up in a chair? Did you totally see that? Oh, yeah. What's extra?
So you're saying one of these updated?
I updated one.
It should just work.
It does, yes.
Yeah. Okay.
Yeah, it does. I got it. It's updated now. Oh, wait, let's see. Yeah, I got it updated.
It's ready now.
Oh, thanks.
Okay.
So how does this work?
There's a bunch of people coming.
Is Kent or Lou in the room?
Shradra?
Does anybody else know about making the remote slide forwarder work with a Mac?
Yeah.
Yeah, I plugged that in.
It's not working.
Oh.
Usually.
Well, maybe.
There it is.
No, it's automatically moving.
That's not.
Yeah, no, it's not working.
Oh. Yeah, it used to work in the past. I see that, yes.
I expect to see a light blinking when you do stuff here. I think the battery.
Oh, maybe it's
And I got a blinky.
okay.
Blinky.
Try it. No. Oh, you're doing something. You just took it out of. Okay.
It repaired, so just put it in full screen mode and it should be fine.
Okay. Awesome. Thank you, Jeff. No, I didn't try rebooting it. Okay.
Yeah, we'll get started. Is Martin in the room? No, I guess Alvaro's it's gonna move from not to the new AD, but I guess Alvaro's gonna be our AD. I don't see him either. So
He's right there.
he is there. Good.
He's hiding in
Yeah.
the back.
So we haven't until tonight. Yes, that's right. Right. Okay. I think I got an email from Aaliyah. I think she's gonna pop her head in. She's gonna be a little late though. We will.
We have to.
Yeah, sign your name twice.
Yeah, because we have.
Or you put your wife's name on.
Yeah. I think we put 75 down for this.
Yeah, yes.
So this is a 75 room.
Uh-huh.
Okay.
Yeah, go ahead.
Yeah, so this is the first official meeting of the merged ISIS OSPF working group. It's called LSR, which, we have to pronounce as laser or something, or LSR, just not loser. Lesser, yeah, that's a little better.
It is lesser protocols.
Yeah, I don't know. So now instead of making fun of each other, we're gonna get made fun of by BGP.
Yeah.
Is that what-
And the first, the agenda of the first meeting is to close the working group because BGP is doing.
Yeah, okay. So we have the blue sheets going around. We have a minute taker, I believe. Yay.
I was going to point out to Russ, you haven't seen my port 179 slides.
Okay.
We have an Etherpad, but I don't know how to get to it. It's you're on the Etherpad.
I'm going to get in. Ying Jen's in there right now, and I'm going to get in there.
You can get to it through the agenda, I believe, right? There's a link,
One of those clicky icons.
little button on the right. I don't know if we have a Jabber scribe.
Yeah, Mikkel.
Hey, Jabber scribe, Mikhail Abramson. Thank you. And our Meet Echo support. Well, that's us now. This used to be a slide they made us read. I don't think we have to read it anymore because they made the text a lot longer. But this is our note well that basically says you agree to all these rules because you're participating in the IETF right now. The bottom two columns are all of our policies and rules regarding this. Okay, so this is our agenda. Did anybody need to make any changes to it? Okay, well then, on to document status. So didn't know if we should merge this. We kept them separate. We'll still do ISIS first and then OSPF after. So we have one RFC misref. It's just waiting for segment routing extensions. That's L2 bundles. The reverse metric is just waiting for a write-up. I was contemplating doing having a separate shepherd for this. So if you're interested in shepherding a document, contact me. The MSD, we're basically just waiting for, OSPF is almost done with this as well. It'd be nice to just do them together so that there's no difference, make sure there's no difference. So the routing extension, segment routing extensions, we're on version 15 now. It's been in last call since April of 2017. I'm going to pull this out of last call because it's not really in last call, right? It's being developed. And we can, I mean, if it's done now, then we can last call it again, right? So, Les.
Les Ginsburg. So it's done. The last comment that I'm aware of was addressed in December. So if there's something I'm supposed to do.
No,
you gotta
it's
tell me.
actually, I don't think it's you. I think AC was telling me this is your thing now. You have the framework as well? The architecture, I mean?
Yes, but
So what I noticed is that this sort of tracks the architecture, right? There'll be a change to the architecture and then like a TLV will change over here.
no, absolutely not.
Okay.
You know, I think we would expect to update a reference because of the SRMPLS, new content in SRMPLS, but it's only a reference change. There's no actual text change.
So you're saying there's no changes for the last 3 months?
Correct.
Okay.
Perhaps
And there are none
Yeah.
planned.
Okay. All right. Well, we'll last call it again, just to make sure.
So you can last call again.
It's
I'm
2
just
weeks. It's
saying
not-
the only difference between the content from like
April?
June or whenever
April.
and now was to respond to comments from the last call. And that was completed in December. So
Okay.
I'm not objecting, but I'm not
I'm
quite
pretty
sure why
sure the
you're-
TLV changed. The TLV changed
No.
between 2017 and now.
No,
You're talking
No.
about SRLG?
Yeah,
That was a
pre.
pre, yeah.
Well, then what have we been waiting for?
yeah, that's why I'm up here.
Oh, okay. All right. Okay, well, maybe this was my mistake. I'm not sure. I mean, it was version 11 in 2017. Was this just IESG editorial?
Yeah.
Four versions worth.
I don't recall it being 4.
Well, I mean, I did look at this morning. It was version 11 was the last call document. Yeah. Okay. All right. 4 versions of editorial changes. We have a new, just adopted the desk source routing. So that's new work. Not being presented today, though. The bold there is being presented today. The Yang, that's a segment routing Yang. I sort of covered the Yang together. I want to talk about the other Yang document. The MSD I already mentioned. These are all being presented. They're individual documents. And then I'll have those dates still sitting there anyway. So, right. So I mentioned this. Yeah, the bold ones are being presented. So I noticed that TTZ got updated here. So what changed since 2015 when we decided that this wasn't work we were going to carry forward with? I mean, I don't know why it's being updated. Unless the comments that were put on during the meeting in 2015 were addressed. I don't know why it would keep getting updated. And also, the OSPF, it did go into experimental with. So, I mean, if there's something to share there, like with some new operational experience, since it was accepted as experimental, if it's been implemented, if it's been deployed, if people are using it, that would be good to know before we start working on an ISIS extension. Geo coordinates. So this, I wanted to mention this because it sort of got pushed to the side. Peter Lothberg brought up that the geo coordinates were not expansive enough. So we need to be able to identify things in space, right? So that got put to the side. I've actually got a model design that makes Peter happy, so I could introduce that, and maybe we could restart this work.
Yeah. I'm an offer on all these documents, and that kind of the open-ended comment we got from Peter kind of put us on. We said, well, we're not going to ask for adoption of these, and other things were, it went from low-hanging fruit to very high fruit to reach. So I think this is, I'll get with my co-offers, and we'll look at Peter's, what Chris has done to encode the geo coordinates that satisfies all the DT requirements.
And that's just a note that's happening in beer.
Mm-hmm. Okay. Actually, I'll stand up. I want to get a little bit. So I'm gonna go real quick today. We have all these documents sitting on the RFC editor queue. The only one I'm going to say something about is the segment routing one. We're going to change this on the queue, only that ref, and I don't think that should be a problem. I hope, because it's now not the conflict draft, as if you've been following Spring, that draft has expired, and the conflicts are now handled in the MPLS segment routing extensions. You can see that tunnel end caps is waiting on this IDR tunnel end caps. I hope that will go forward in the next 2 IETFs. The two at the top, link overload and extended LSAs. Extended LSAs is actually off 48 hours, so that should be pretty quick. Link overload, I'm hoping that'll get to there's nothing stopping, it's just the RFC editor workload. These 3 documents, I want to working group last call. This may be a bit ambitious because there's 3 of them, but to do them all before the next IETF. There's nothing other than ELC. I'm thinking we should wait on MPLS. I'm going to go to MPLS tomorrow, see where that one's standing. But otherwise, there's technically there's nothing that should keep us from working group last calling these three. And all the other drafts, all the other working group drafts, not individual drafts, are presented today. So I'm done.
Okay. Much more efficient than me. So first up, I think, is the Yang. Yeah. Okay. So it doesn't do PDF to.
Good morning, everyone. I'm Yingzhen, and this is an update of the OSPF Young model. So we have been working on this for 3 years. We hope this will be done soon. This is the changes since last time. So the first one is because of the BFD model is finishing, so we finally knocked down how we interoperate with BFD model. That's the change we did for that part. That's the first bullet. And then we had a young doctor review of the whole data model. These are the detailed changes we did. I think pretty much we have all the major issues addressed, still a couple of cosmetic issues. We will finish it in another update, and then we will start this last call. So the real major changes is this part. So we used to have a OSPF instance list, and inside is OSPF instance, we have a list of address families. Now we remove that instance list, also the address family list. So right now we only under routing config model. So under control protocols, the list is over there. So only one OSPF instance, and each instance has only one address family defined. So that's pretty much all the changes since last IETF. And then we want to last call OSPF model as soon as possible once we address all the young doctor comments. And then the next one will do the ISS young model. OSPF SR and ISSR, I guess we'll wait until the last call of the architecture document is done and then finish up those two.
Is Stefan in the room?
Yeah.
Oh, good. Yeah. We're going to start the design team meetings on ISIS after this IETF and take what a lot of the comments, some of the comments we've gotten from the Yang doctors and apply them to ISIS.
I think that's apply to ISIS also.
Yeah.
But we still need a formal review, right?
Yes,
Formal
oh,
young
definitely.
doctor review for ISS model.
Oh, definitely. Yes.
Yeah, so that one probably after next IETF, I would expect we can last call.
Wait.
Uh-huh.
So, no, I wanted to go faster than that, I think. So the BFD, I'm not sure why we didn't just make the BFD change at the same time, but I also don't like ISIS next priority. It's just equal priority. But primarily
That
we're
just means sequentially.
save the best for last, right? So, so anyway, we need to push these faster, right? So
Yes.
let's get all the Yang doctor review that stuff that you got from OSPF. Let's make the analogous changes that you made, right, to make it BFD compatible. Let's last call it, and let's
Have to start the young doctor review.
yeah, but let's do all that before the next IETF. I want to
Yes.
let's have it be an RFC before the next IETF, right?
That would be
There's
good.
no reason to wait for another IETF meeting to get this done.
Cool. Thank you.
Oh, that's it. Thank you. Okay. OSPF reverse metric. What in the heck is going on with that screen?
No, it's not working.
Hi. So this is the OSPF reverse metric draft. It's the first version. So what does this draft propose? The idea is to have enable OSPF V2 or V3. It applies to both router to be able to signal to its neighbor the reverse metric that it should use towards itself. So it's very similar to the ISS. ISS draft in that sense. We'll talk about that. So the router R1 uses the reverse metric signaling towards its neighbor R2, and this is done on a link local mechanism. In response to this, R2 modifies its metric in the router LSA for its link towards R1. And this is a mechanism which needs only support on by R1 and R2. Other routers in the network are really not involved in this, and they just use the updated metrics in the router LSAs for their SPF. Couple of use cases which wanted to capture. One of them, the first one is many OSPF deployments use this notion of an auto cost based on some reference bandwidth, which means that the metric of the link is determined based on the bandwidth of the link, and this is in some deployments this is symmetrical in both direction. Now, as some of these networks are evolving to more complex layer 2 aggregation with Ethernet, the physical topology and the layer 3 topology are different. So in these cases, there are some use cases where the link down in one direction towards a switch. In this example, let's say from R1 to R0 is not necessarily detected by the other router. So it doesn't know or it cannot update the bandwidth. What does reverse metric mechanism would allow in this case is that the router which detects one of its link capacity going down, let's say one of the links going down, can signal to its neighbor to reduce or increase the metric rather in the other reverse direction as well. So it's still symmetrical and there is not going to be congestion in one direction on this link. The second use case is when there are, let's say, a couple of aggregating routers which are connected to a bunch of access routers, and due to some capacity degradation or congestion towards the core network, one of the routers, let's say in this example, the aggregation router 1 wants to shift or offload some of the traffic coming towards it to another router, and this can be signaled by the AGGR R1 via the reverse metric mechanism to, let's say, one of the routers R1 in this case, so that the cost of the link goes up and the traffic from R1 to the core picks or gets shifted to the other router. So how is this?
Can I make a comment?
Sure.
So your use case 1 can be much simpler, right? I mean, so take the case where you have a fiber optic point-to-point connection, right?
Mhm.
And you're on the receiving end and you see that the signal sucks and it's got a lot of errors. You don't need all the aggregation switch, right? So the neighbor knows that it's get crap, but so it tells its neighbor, hey, raise the metric.
Yeah, that could be a variant, yes. So how is this done? This is the proposal is for new reverse metric TLV, which is used for link local signaling. And it really has the reverse metric value, which is advertised there. There are two ways in which this can be done. There is the O bit or the offset bit, which is what it indicates is that the value advertised there is a metric that needs to be added by the neighbor to its existing, the original metric. And the other option is the H bit, which is really indicates, which is actually the, what it indicates is this is the absolute value, and this can be used by the neighbor, provided this value is higher than the existing metric. This TLV is included in the hello message as long as the reverse metric signaling needs to continue.
In case of LAN, you have to use two-part metric, right?
Yeah, it's coming in the next slide. Yeah. Oops, sorry. So, so this draft applies to point-to-point and point-to-multipoint links only. We already have in OSPF the two-part metric, and that mechanism can be used for broadcast and NBMA networks. So this thing. The one difference in this draft as opposed to the two-part metric is this is link local, and there is no backward compatibility challenges and the area-wide capability things which come with the two-part metric. Now the exact mechanism for triggering this reverse metric, what is the value to be used, whether it's something done by a management station or it is done by the router, those are implementation aspects outside the scope of the draft. The draft really focuses on the signaling part of it. Since we also have the ISIS reverse metric, wanted to quickly touch upon what's the differences. So
I'll just speak loudly.
No, you go to the mic, please. There are people that are remote that cannot hear your loud voice. Yeah, you can't get loud enough.
Okay, all right. Yeah, Himanshu from Sienna. How does it revert? Do you have a scheme whereby it reverts to the original value?
yeah, so you just stop including the TLV, the neighbor would revert back to its original value.
I see. So you have to keep
Yes.
refreshing it.
Yeah. So the difference really is that the ISIS draft covers a variety of use cases, but we already have different mechanisms to do that in OSPF. So the two-part metric handles the signaling in LAN cases. We already have the link overload, which is going to be RFC, which handles the link overload signaling. This particular draft, let's say, handles a hole or a missing case where we wanted to do it for these other generic use cases as well. The other difference is that ISIS draft only allows really offset mainly in addition to the overload scenarios. But here, because of this deployment use cases where we have this auto cost kind of a thing, reference bandwidth deployments, the OSPF draft also allows for signaling of absolute value. So look forward to review in the working group and comments, inputs.
How many have read the draft? Okay. We'll discuss more on the list. You can initiate the discussion. Okay. Yeah. Thanks.
Okay.
That's right. I think so.
Yeah.
Seems like the IETF internet access is excruciatingly slow in this room. I don't know why.
Need a bigger room.
I don't know. Yeah.
Count the number of laptops.
Yeah, I guess.
Okay, I'm Les Ginsberg. This is a presentation of an update to the ISIS SRv6 extensions. This version 2 was published just a couple of days ago. Apologize for that. We didn't quite make the deadline. before the IETF. But this presentation is based on that. There are two key documents that you need to read in order to fully comprehend what's going on with the IGP drafts. I'm not going to talk about a lot of the basic concepts, but the network programming is sort of the architecture document for SRv6, and the 6-man document documents the segment routing header for IPv6. So those are key background documents that you need to have looked at. I did want to mention there's an equivalent OSPF-B3 draft. I think we didn't have time on the agenda to present that, but it's basically aligned with the ISI's draft in terms of what it advertises. Oops, too fast. So what have we changed since V1? A lot of this is editorial. We've aligned with the latest version of the network programming draft, which introduced some new names, and particularly introduced a new registry for the functions, or the endpoint types as they're now called. And we now refer to that registry. Previously, we had defined values for them in this draft itself, but now we have one common registry for that. We've added support for OAM in terms of what the IGP can advertise. We had a sub-TLV for the function descriptor, because originally we had some thoughts that we might want to associate multiple functions with a single SID. We've now decided that's not needed, and so we've gotten rid of the sub-TLV, and we now encode the function directly in the SID TLV, which I'll show you. And we've done some editorial changes in terms of naming that we thought was a little more intuitive. So what does this introduce? It introduces a new SRv6 capabilities, which is a sub-TLV of the router capabilities. The SR capabilities that we all know and love is for SR MPLS, so we needed a new one for SRv6. We introduced a new top-level TLV to advertise SRv6 node SIDs. We have endpoint function types associated with the SRv6 node SIDs. Again, we'll show you that. And we also have SIDs associated with a neighbor, sort of the logical equivalent to adjacency SIDs in SR MPLS. So this is what the SRv6 capability sub-TLV looks like. We have flags. There are two flags defined currently. One of them to indicate whether you support the TNCAP function. And if you want to know more about TNCAP and all the other functions that are mentioned here, it's the network programming draft that's your guide there. And it also indicates whether the box supports the O flag for OAM support. And then there are optional sub-TLVs. These are the sub-TLVs that are currently defined. They're basically a collection of things which indicate, should we say, the maximum imposition of various types of SIDs in the SRv6 environment. And again, network programming guide is your best resource to get all the details on this, as far as what these functions actually do. There is a general descriptor for the endpoint function, and it looks like this. We have 8 bits of flags. Currently, there's no flags defined. And the actual function value. These functions, again, are defined in the network programming draft. And this is the list of functions that the IGP will be advertising. So we have the node SID TLV, which is a top-level TLV. If you're not SRv6 capable, then you just ignore this. It's important to note that a node SID, this is not a prefix. This is not something that's going to be installed in the forwarding plane. And one of the reasons that we chose to introduce a new TLV, one could have imagined that we could have done sub-TLVs of the IPv6 reachability TLVs, but in particular, we didn't want to have this impact on the nodes that are not SRv6 capable. So by introducing a new TLV, the nodes that don't support SRv6 simply ignore this. They don't know what it is. This is used for SIDs that are not related to namers, or if you like, in SRMPLS terminology, it's the equivalent of a node SID or a prefix SID. It does, as I said, it doesn't cause something to be installed in the forwarding plane on its own. It does share the same sub-TLV space with the reachability TLVs because we do envision some use cases for some of those sub-TLVs. And it can be leaked between levels, similar to the way a prefix reachability advertisement is leaked. And just it's possible that the SID, which in SRv6 is an SRv6 address, isn't necessarily covered by a prefix that is advertised by SIS. It could be advertised by another protocol. It could be a static route. So this is what the TLV looks like. We have flags. There's one flag bit, which is the D bit, which is used in the same way that it's used in the prefix reachability. So if you leak it downward, you set that bit. The function flags and the endpoint function value is what I described on the previous slide. And the function variants that can be advertised in this TLV are the end and the end.otp, which is an OEM related function. And then we have the actual SID itself. We've encoded this very much like a prefix. In most cases, it'll be a /128, but we've allowed for the possibility, if it isn't, that just like we advertise prefixes today, we only have to advertise the significant bits. And we've allowed for sub-TLVs, but there are no sub-TLVs defined presently. Similarly, we have an adjacency SID sub-TLV. This is advertised in the IS neighbors advertisement. It has the same structure as the node SID. So again, you have the flags and the functions and the actual SID itself. In this case, the function variants are the n.x and n.dx flavors, which are sort of functionally similar to adjacency SIDs as you know them in SRMPLS. There's a similar advertisement for a LAN. The only difference on the LAN, of course, is you have to advertise the system ID of the neighbor to differentiate which neighbor you're talking about. And at this point, we'd like to ask for working group adoption. Questions?
So how many people have read the draft? All right. How many people think this shouldn't become a working group document? And how many people are interested in working on this in the working group and it becoming a working group document?
I guess
Okay. So, yeah, no one didn't want it to.
So I just have one question. Well, I'll let Randy go first. Go ahead.
Randy Bush, I'm a spy from the NOC. With speed test, I'm getting 275 megabit download in this room and 174 up. Come see me in the back of the room with your laptop. And if other people are having trouble.
Was that inspired by AC's comment? Or
Yeah, probably was.
that's what you get for talking up AC.
That's what
Okay, I think let's move to your next presentation.
Oh, okay. I do have one question. So the SID size, that kind of confused me. I didn't read this until coming over on the plane. That's going to be 128, but it was just put in there in case we wanted to do something to make more compact SRv6 header, right?
There are
Proposals.
There are some potential uses for that,
Yeah.
but we haven't decided yet. But
Who's
thought-
we? Who's we?
We as in the authors,
Oh, the offers. Okay.
there's no hidden,
Okay. Okay.
no spies on this one. so,
Okay.
yeah.
The other thing is, you said that this isn't installed in the routing table, but it is in the same sense like the MPLS said it would be in the SRv6 header as for individual reachability to individual FEX in the like a prefix or something else in that is in the forwarding table.
Yeah.
Correct. Yes.
So
If we
you
used to-
certainly use it in packets. You will see it
in the SRv6
in
yeah,
packets,
headers.
of course.
Right. Right.
But you can, with SRv6, you can easily imagine, in the simplest case, that you have one summary address that's advertised that covers the reachability for all of the SIDs that a particular node may advertise.
Mhm.
So,
Okay.
okay. So this is an update, and in the spirit of the joint working group, this is a joint presentation for the ISIST attributes and its OSPF v2 equivalent, which is the traffic engineering reuse. So I'm going back two IETFs because the two documents were updated at different times along the way, but the two documents are now fully aligned. So they've been adopted as working group documents. We have introduced some additional standard applications since the earlier drafts. We've clarified the relationship between attribute advertisement and whether that indicates an application is actually enabled on an interface. We've also made some clarifications to the list of link attributes that are supported. And in the case of OSPF, the neighbor interface address or link ID in the case of unnumbered has been moved out of the OSPF draft to the link overload draft.
Last just one. And you'll recall from the status that is on the RFC editor's queue. That draft.
Of course, I remember that, yes. Okay, so we now have the following standard applications. We have RSVP-TE, we have segment routing, SRTE, we have LFA, and we've now incorporated the Flex Algo. There'll be a presentation on Flex Algo later today. For application enablement, we've now clarified in the case of RSVP-TE that if you advertise link attributes and you specify the RSVP-TE bit, then that does indicate that RSVP is enabled on the link. For the other application types, that's explicitly stated as not the case, that it does not indicate enablement of the application on that interface. So this maintains, I think, the existing paradigm that RSVP-TE is explicitly enabled on a link, and it's associated with the link attribute advertisements. And this addresses an issue that had been brought up in a draft from Chris Bowers and Shraddha, wherein in existing implementations, not everybody agrees on exactly which link attribute indicates RSVP is enabled. With what we specified here, that's no longer ambiguous. So these are the statements about each of the applications as to whether it indicates that they're enabled on a link or not enabled on a link. And we've specified that if you introduce new applications in the future, that you are required to state whether the advertisement of link attributes to be used by that application indicate whether that application is enabled or it does not indicate that it's enabled. That's a requirement of any application that's incorporated into this functionality. So here's the list of supported link attributes, and we made some clarifications on particular link attributes. In the case of link bandwidth, this is clearly an application independent attribute. So when it is advertised, if it's advertised associated with multiple applications in different sub-TLVs, then the value must be the same. In the case of maximum reservable, we're allowing for the possibility that there are application use cases. I think it's in the most common use case, this will be shared among all the applications that are using a particular link, but the infrastructure that we have allows for the possibility that you could have different values for different applications. Unreserved bandwidth is an attribute specific to RSVP, and therefore it can only be advertised with RCP if it's associated with some other application that's invalid. So we'd like to, this is already a working group document. There are now some implementations, and we really want to get early allocation of code points so that those implementations can proceed and also continue the discussion.
Seems reasonable. You're one of the approvers of allocations.
So are you. Well, I mean, there's a,
No,
I
I'm
forget
sure.
what the official process is, but
I'm sure that the people would say you were doing secret stuff if you did it yourself. And what is restart signaling?
Let's just ask the negative question. Does anybody have strong objections to early allocation for either protocols drafts? I mean, code points. Okay. Yes. Okay.
That was funny.
Okay. We'll take it to the AD, and at least for OSPF, this is an existing RFC, and the allocation policy is standards action.
Oh.
For RSCs.
You did
it's
that.
different for,
You did that to yourselves?
Yes, we did. Yes, we
Okay.
did.
It's easier in
I believe we
ISIS.
I believe we did it. I think it's the prefix link attributes RFC. I'm an author. I should know that, but I think we did, if I recall. Okay, good.
All right.
okay. Tony, I think you're probably in a time warp now, but so there's an existing RFC for graceful restart, and it's about 15 years old. But there's an update that we are proposing to it. So how does this work today? Today in Hellos, if you have a router that's undergoing a control plane restart and the forwarding plane is maintained, we want to be able to support a hitless transition. And so we have this TLV that we insert in the hellos, and the restarting router sets the RR bit to say, hey, I'm restarting. On the neighbor, if the neighbor supports the helper mode, then the neighbor sends an acknowledgement via the RA bit, and then starts the LSPDB synchronization so that the restarting router can quickly reacquire the current state of the link state database. So what's missing? Well, this works really well if your control plane restart takes a very short amount of time, less than the adjacency hold time. It's useful, again, it depends upon your implementation, but it can be useful for process restarts. It can be useful where you have redundant control planes, but for whatever reason, you haven't implemented any local checkpointing, so you need to reacquire the link state database from your neighbors. But it does not support a reload of a control plane that takes an extended period of time, such as 2-3 minutes. You can hack this by sending a hello before you start your planned reload and extend the hold time. But the risk associated with this is your neighbor has no clue that you're actually restarting. He just sees, oh, you want me to have a longer hold time. And if there are topology changes which occur during this extended period when you're restarting, the neighbor has no reason to think that you're not receiving the updates. And so this can lead to traffic loss. So what have we introduced? We've introduced 2 new bits. So we use the same TLV in the hellos, but we've introduced the PR bit and the PA bit. PR bit signals to your neighbor, I am going to do a planned restart. But unlike the RR bit, it says, I haven't finished my reload or restart yet. So don't start sending me the link state database. I'm just telling you that I'm about to do this so that you're aware. And it still provides the existing mechanism, which says I can extend the whole time. But the difference is now the neighbor is aware that you're actually restarting and can take this into account should there be additional changes. So what does the neighbor do when it receives PR? It keeps the adjacency up, assuming the adjacency was in the up state already. It marks as an internal state that, hey, my neighbor's in planned restart state, updates the whole time, but updates it only once. So if it gets another hello with the PR bit set, it says, hey, I'm already in planned restart state. I'm just not going to update the whole time. And it sends an acknowledgement. The plan.
Can I ask a question with that? Why? I mean, like, why not like let it, because maybe it got busy and didn't start restarting, and so it wants to send it a refresh.
Well, I think the danger here is that, something goes wrong and you just keep sending this and it keeps maintaining this adjacency forever. There's what I would expect people to do is to send the PR and go, okay, based on my platform, I need 3 minutes for this. So they'll set the hold time to 5 minutes or something generous. So I don't think there's any need to keep updating this. This is supposed to be a limited time period, I'm not supposed to do this forever. So, plan restart state gets cleared when you receive a hello with the RR bit set. That indicates the router's now actually has reloaded and it wants to start reacquiring the link state database. Or you could receive a hello which doesn't have the restart TLV at all, or it has the restart TLV and it doesn't have either RR or PR set. And of course, if your hold time expires, obviously you'll take the adjacency down as normal. So what does the neighbor do? And this is the value add here. Since the neighbor now knows that, okay, you are restarting, your forwarding plane is maintained, but it's not getting updated because the control plane is busy doing the reload. If topology changes occur, then the neighbor, and we introduced this as a may because you could put some intelligence around this depending upon the significance of the topology change. Maybe a topology change occurs which doesn't affect any traffic transiting the restarting node. But the neighbor now has the choice to bring the adjacency down, saying there are topology changes, there's nobody home in the control plane on my neighbor. He's not going to, if I can send him the LSB updates, but he's not going to process them. If the restarting router is the DIS on a LAN, DIS is responsible for driving the update process on a LAN. So if there's a topology change, then we should definitely bring the neighbor down in that case. If you're on a point-to-point circuit, knowing that your neighbor is in a planned restart, if you like, you can optimize and simply not send LSPs and SNPs during this period because they're not going to get acknowledged anyways. And if you're running BFD, and you have support for the control plane independent bit in BFD, then knowing that the neighbor's in planned restart state, if the BFD session goes down and the BFD session shares fate with the control plane, you could safely ignore the BFD down event. So that's it. Comments?
Hi, this is Suma. It's good to write what are the changes from RFC 5306 in the beginning, because when I read it, the draft, I can't figure out what is changed unless I see this.
But I just told you.
So I had this, I had this
But yeah.
exact, I had the same thought, like, I don't know why we don't just require a changes section for all BIS drafts, right?
So I don't, to be honest, at this point, I don't remember, but traditionally we put them in the appendix at the end.
Yeah, yeah,
If I didn't do that, I certainly will.
yeah, yeah. I mean, I wonder why we don't, but yeah, that would be good.
Also, one more comment. I have specific comments on database synchronization. We have issues long back, 10 years back when I was coding this part. I will post it in the mailing list.
So have you thought about the people who did the graceful restart without using all the protocol mechanisms?
So you mean not graceful restart?
Yeah,
You mean,
the cool way.
yeah. So this in no way is trying to promote the use of graceful restart where it's not needed. But there are use cases where you have a control plane restart and it's going to take a while.
Right. So what I was getting at is if you're choosing to use the cool way,
Then you don't need this.
No, you don't.
That's always been true.
yeah.
And this is, I'm not promoting graceful restart. I'm just trying to make it more useful. This, in fact, is introducing into ISAS what OSPF has always had with the Grace LSA. That's effectively what it's doing.
So I guess I'll talk to you a little bit later about this, but the refreshing the hold time, if you drop the acknowledgement, I mean, if the, you could continue to send it, your protocol mechanism, you could be waiting for the acknowledgement and that hello might get dropped. And
Well, so if you're the restarting router, your plan recommended, and we're now getting into implementation details. I wouldn't send this just once. I'd send it several times before I actually go down, because hellos are unreliable, and you want to make sure, as sure as you can, that the neighbor has received it. But of course, there is the acknowledgement mechanism. So once you get the acknowledgement,
so you would pad the hold time to count for all those extra hellos. Because it's not going to refresh.
I don't see why do we need to cut this so fine?
I don't know. It just can't all be about TLV picks, right? We're going to have a little fun in here.
I just had one comment. Does ISIS normally does not terminate helper mode when there's a topology change, right?
We can't today because we don't know in advance. So what we get today
right.
is we get RR, which says, I have restarted. I need you to start sending a link state database.
Yes. Right,
So-
right. But even after that, you don't.
I suppose it could be a local decision that says, hey, I'm in the middle of resyncing the LSP database, and there's a whole bunch of changed topologies, changes in the topology. I suppose people could implement local logic and say, yeah, I think this is too dangerous.
Yeah, no. OSPF it's directed to, and the RFC says you're supposed to default if you detect a topology change to terminating it. But everybody defaults the other way and does a best effort graceful
Yes,
restart.
but this is tied to the Grace LSA.
Yes.
So the point is, in advance
Yes.
that the neighbor.
But there is one good point you made, and we are doing some extensions. I'm working, I think, from the people from Brocade or someplace on a draft for the graceful restart extensions. And I think I should put this piece in about handling the DR, because right now it assumes that you terminate helper mode, and what a DR should do, or DIS should do, is advocate the DIS role. That would be one other thing you could do, as opposed to terminating graceful. If you know you're going to restart, you could abdicate. You could do a DIS election and advocate the DIS role, right? I think that would be a more robust solution.
You could, but there's potential disruption, small amount.
Yeah. Okay.
But this, to me, this does not have to be specified. An implementation could choose to do that.
Thanks, Les. Peter's up.
I'm Peter Shenak from Cisco. I'm going to cover the segment routing extension as a first item. So there has been a significant rewrite of this draft. Basically, we put it in a parity with OSPF v2 SR draft. So one thing that we removed from the draft was the SRv6 because the SRv6 extensions are now in a separate document. So the whole section 3.5 was removed. The seed label sub-TLV, the binding sub-TLV, the seed label sub-TLV code point changes from 3 to 7 because the 3 has been used for the tags in the OSPVC LSA extended. We changed some of the code points for SRLB and SRMS preference sub-TLVs because, again, these are shared with the OSPF v2 as a router information sub-TLVs, and some of these values has been used for other extensions. So the binding TLV has been removed. This has been removed from the OSPF v2 as well, so it's the same change there. We added the support in the range TLV for the IPv4 address family because we can run OSPF v3 for both IPv4 and IPv6. So we added there. We changed the values to be, the same for the IPv4. So we used the value 1 for v4 and value 0 for v4 and value 1 for v6. So we are in sync there. There has been a security consideration added, references has been updated, and a lot of comments that went into the OSPF v2 SR draft as a part of the various reviews in the process has been incorporated here as well. So basically, this document now has all the review comments we got through the OSPF v2 review. So I guess this document can be last call, I guess, because it has everything it needs at this point. So
Did we, AC Lindum, did we ask for early allocation on these code points yet? I know.
yes, we did.
I know Nokia was implementing it, so.
I believe so,
I
yes.
believe so, okay. So I'll tell you what let's take one review. I'm going to take one more pass over now that we have this, now that we have the extended LSAs is about to be published. Yeah. And we'll try and put this on the list of things to start the working group last call before the summer.
I mean, one thing we need to change is the reference from the conflict resolution to the other draft.
Yeah, that's trivial. Yeah,
but that's trivial.
Yeah,
that's the only change I know about.
Okay. So I'll commit to doing a good review on this. One thing Chris and I have been talking about is trying to get some other people involved in shepherding. And so I'll look to see who's not an offer on. The problem with this one is there's so many offers, it's harder to find shepherds. I'm kidding.
Make some shepherd, right?
Yeah. Yes. Okay, thanks.
All right. So can we go to the LLS?
Yeah.
That's going to be quick. What was the LLS?
All right. So this is going to be quick. This is a very, very simple extension of how to advertise the interface ID in the hellos using the LLS extension. This document has been presented several times. It's very, very simple. There has been no changes. There is a backward compatibility section with the RFC, which uses the local LSAs. I mean, we have even the early code points allocated. We have implementation. I guess this is the next candidate for the last call.
So you want to add?
See how many people have read this? I have a couple times. Is there anybody who doesn't think this is ready for working group last call? We'll take it to the list, of course. Okay, that would be this. I think I'd put this ahead of OSPF v3 segment routing because that needs much more review than this one would.
This one is simpler for sure.
Yes, I'd put it on probably on the list of those four those long time documents that we'd like to finish.
Flex algorithm. This
Yeah.
bracket one,
Yeah.
right? AC edited this file. I don't think so.
All right, so the next item is going to cover the Flex algo extension. So now we have both OSPF and ISI's drafts describing, it's the same thing, the only difference really is the way we encode. Oops. So, I mean, this has been presented before in the last IETF. I just go quickly and describe what the Flex algo is. I mean, we have the algorithm types registry, which has the values from 0 to 255. Basically, what we want to do, we want to use half of the values for user-defined values. And what it is, we call it a flex algo because it's defined, it has the flexibility for a user to define it. It says the flex algo represents the set of constraints, which is affinity, exclude, include, whatever we can introduce in the future. It has a metric type associated, so it can be either IGP metric, can be delay, can be T metric, can be whatever exotic stuff we can add if we see a need. It also is an algorithm type, which means what type of computation do we want to use. So basically it points to one of the standardized IGP algorithms. So we can use SPF, that's what the draft uses today. We can use something else if we need to in the future. So it is user-defined. User has the flexibility to associate a value with this set of metric constraints, algorithm types, etc. Now, it allows the IGP to compute the path for the destination using these constraints on top of the topology that we have. We are not doing any multi-topology here. We are not defining new topology. We are doing this on top of the existing topologies. The way we forward the traffic for the Flex algo is we use the algo-specific prefix SIDs, and this is a distributed computation. Everybody uses the same Flex algo SID, and we use that SID to forward the traffic using these Flex algo paths. So that's what the draft is talking about. Okay. So there has been some changes. If you read the first version of the draft, okay. So we used to, I mean, most of the discussion in the draft talks about how do we make sure that the routers in the network agree what the definition of the particular algorithm is. And we had two ways to advertise it. We simplified it. We only advertise it in the router capability TLV. We have this, what we call a flex algorithm definition sub TLV, which basically tells what the algorithm definition means, so everybody agrees and can do the consistent computation. The original version talked about the conflict. So when the conflict was detected, basically the outcome was that we stopped the computation, removed all the forwarding associated with it. We changed this, and basically we changed it to deterministic selection, where we put the priority field in the sub TLV, and then we also use the router ID to select if we have a conflicting definition coming from a different routers. We added the algorithm type so we can support non-SPF computations if needed. Oops. I'm clicking too fast. Sorry.
That's okay. That one?
Yeah, that one. So we added, so originally we had exclude affinity as a constraint. We added include any, include all affinities, so we have more flexibility. And we also updated the section which talks about how do we compute. So there's a whole section talking about what do you do, what are the steps, what is the order. So, the computation is consistent. There's been a lot of editorial changes to make it clear and easier to read also. So we have also the 0 version of the OSPF draft, which is the same thing. It's just that the encodings are different. So there is at least one implementation, maybe more, I don't know. I know about one. We would like to make this a working group document and allocate the code points so we can, use it in the implementation. And one proposal, I don't know, it would be interesting to see the feedback. Maybe we can even merge these two drafts and have a first LSR draft where we specify the extension for both OSPF and ISIS. Because if you look at the text, it's exactly the same. The only difference are the different encodings. So that is a possibility. You can keep them separate also.
Oops, sorry. Yeah, go ahead.
Andrew Dolgano, Nokia. First of all, thanks for bringing this up. It's definitely interesting work. Few kind of comments. Probably it's extremely misleading calling this segment routing flex algo because it's not it's an IGP and not segment routing. So I would, and there are already use cases talking beyond segment routing. So I would like authors to kind of change that and focus on IGP. We're using IGP registry. We're moving it to IGP. I would like also to know, have we decided to work on flex algo here or in routing as a concept? Because where it used to be developed was a little bit kind of offside, so to say least. So great that is brought here because there's more visibility and it's a great work. Let's make it IGP and not segment routing.
So we are using segment routing as a forwarding plane. You can use different one. So I agree we can make it more independent, but the reason why we brought it up with the segment routing because we have a very easy way to forward using the SIDs, which are algo specific. Right?
Sure, but we're not computing segment routing. We're computing IGPs.
No.
So
sure.
I think what we want to make sure.
No,
is an
definitely
IGP
this is IGP computation, and we can use different control planes. So I got the point. Regarding the work, I think it belongs here because this is all about IGP and distributed computation. So I think this is the right working group. I don't know. Maybe chairs can.
No, we agree that it is.
Tony P. Juniper. So yeah, sharp knife, but I built my set of sharp knives, so I won't argue that, right? My comment will be to say, I'm the last one to throw a stone, right? But people complain about my stuff. I look at this.
Now you can complain too.
So I kind of echo Andrew's comment. I mean, we have discussion with the authors. I think to justify this kind of architectural push, for so much work, I mean, there will be significant amount of work to put it in and make it all working, and it will affect a lot of technologies positively, right? You can apply it to we're talking beer, other stuff, that it would really merit the effort to clearly split it off SR, right? And SR being one option, and LDP, soft GRU, whatever people want to throw at it, being easily usable as a forwarding plane as well.
So we can talk about how we do it. We agree in the principle.
Yeah, we agree in principle. So that's the comment.
It's more like procedure stuff. Okay.
Hi, Peter. This is Uma. I read the draft. I agree with the first comment.
Okay.
It has to be not for SR, but for example, ISIS, you have to do SPF for level, each topology, and the next hierarchy should be algorithm. One topology could be multiple algorithm, multiple data planes. So
yes.
the hierarchy should be set correct.
Yeah.
So it should be not only for SR, for any IGP multi-topology.
Okay.
And just to add on the last comment, whether we're gonna do a single SIS, single LSR or two, it's probably worth use this to set some kind of way forward, because this is just the first one. There will be more of those. Are we gonna go forward, since we merged two groups in LSR, creating one document that covers both ISIS and OSPF, which is a value because it shows a lot of similarities, or do we wanna have separate? That's more question to chairs really than you.
I have my opinion, but
I would.
So I think
Some
that
guidance would be nice. I think. That we
Alvaro
discuss
wants
on.
to talk first.
He's the boss.
AD is taking the mic.
Yes, he's here to forbid a sleeping giant.
Alvaro, than a future reader of all the drafts that come out of here. So obviously, because I have to read everything, I want less documents. That would be better, especially if the text is the same. I don't want to say well, this draft says that, but this other draft says this other thing, right? Now, having said that, I think I don't think it's a good idea to make a blanket policy that covers everything, because there's going to be exceptions. There's going to be cases where I don't know, one protocol has to require more work than the other protocol for the same type of thing, and it may not make sense. I think this is something that we need to look at, maybe on a case-by-case basis. I think the chairs are probably in a better situation to look at that. The other thing that Kara brought up in the back is conformance. As we look forward, and vendors have to be conformant with an RFC, and they only implemented one of the protocols. Why? I don't know, but they only implemented one of the protocols. Are there issues there? So those are things that maybe we need to consider. Maybe there are other things. As I said, when it makes sense, yes, I would like to see less drafts, but I understand why we could have two drafts for the same type of solution.
All right. Yeah, I think also not just the implementation. I don't know how much this matters, but we do have like the ITU connection with ISIS, right? So if they were looking at the standard and there's OSPF, they're like, what's this?
So experience to something related, but not exactly matching. You can very well set up something like a framework document, explaining technology, setting up the architecture, and then you have per protocol specific implementation. Okay. So yeah, you have 3, but that's the clean framework to move forward.
Try to make 1 out of 2. And you're making 3.
But now think the realities of implementing the stuff, or replying to RFPs, right? Moving one document and then, 2 things stepping on each other, doing a ref, albeit the other protocol didn't change, right? And replicating text into documents is almost worse, right? Because then they subtly start to go out of sync architecturally. You put as much complexity as you need to do the work done, but not less and not more, right? So.
Yeah, I think that the way I originally thought about this was that we could look at joining things where it shared commonality between the IGPs. There are differences, right? There's the DD exchange, versus seal and
the encoding is going to be always a bit different.
Well, no, but I mean the actual protocol function, right? Yeah. I mean, there's so if anything relates to that, I think that obviously
needs to be
split.
separated. Absolutely. Yeah. But for things like this,
or where the granularity of the information is so much different. Where ISI sits in a single LSP,
right?
Where OSPF it has, the dynamics change, and there are considerations related to those. But for the capabilities of a router for algorithm, they are, the dynamics are exactly the same for this one. I could see this one would be a good test example.
The Vanguard or whatever.
Yes.
Yeah.
So I think this whole thing about, is this really a big concern about conformance? That we'll take that to the list question, whether it would really disappoint people if we combine a document. I mean, from my perspective, this one I think would be a good one to combine.
Yeah, I agree on that, and I would like to congratulate all vendors who just pick up RFCs and implement everything in them, because of conformance is a concern.
Michael Abrams. So I can tell you, I once asked a vendor to document one RFC, every should that they did not follow, and they did not have that documentation. And this was one of the major vendors. So this is just not done if we're talking about that. And I think it would be a major undertaking. I would like it to be done, because it would be an easy way to say, like, where did they deviate from the shoulds? But nobody does this as far as I know.
Okay.
Thanks.
Just not sure. So in terms of conformance, maybe having this clean separation of functionality per subsection. So you could say I support RFC X section Y would be a good thing to do, rather than trying to address both protocols in the same section.
Yeah, I just have one more thing. I'd encourage everybody to look at this one early. That we're asking. I know we haven't asked for adoption or anything, because there's a lot of flexibility here. Just make sure everything. I don't know if you followed the beer algorithm discussion, but it got almost till the document was almost to the IESG, and then the encoding changed. So let's get this, make sure everybody's happy, or at least we've reached consensus on what we have here for ISIS and OSPF.
So just to comment on the word should, it tends to get used in two different ways. One is that this is very good practice to do this. The other is that this is what you should do 99.9% of the time, but we know that there's a couple corner cases where it would be the wrong thing to do. So that, you can't quite say I follow this should or not. Yeah.
Maybe we need a should unless you shouldn't.
That's what I would, as a customer, I would like to know that.
Hello, everybody. My name is Uma. Myself, Jeff, and Ingin put this document. This is NSP document. I'll define what is NSP. NSP can be, it's non-shortest path. It could be a TE path, or it could be some FRR path, or it could be some segmented path in some deployment use cases, like, where you need to chain a couple of things. Simple SR network. It shows router A1 to A7, B1 to B7, and all the sits are marked. Wherever the number is not there, the metric is 1, bidirectional metric. It's a path from A1 to A7 with the blue line. It's the shortest path. It will be represented in the data plane with 1 label. We know that. And it's a purple path where it takes 8 labels to represent. It has a couple of adjacency sets and nodal sets together to represent that. If you're using SRMPLS, it takes 8 labels. And if you do SRH, it takes SR8, SRV6 sets. And the labels in MPLS case can be more. If you are using entropy, based on the RLD capabilities, you need to insert ELI, EL pairs. So the number could be more. So what are the issues? There might not be any issue for large label stack. It's okay, some good hardwares. If deployed with capable hardwares, it's okay. But there are 3 problems we identified. One is the fragmentation issue, MTU and fragmentation issues. Some deployments is very sensitive with large label stacks or with large SRH header. And the second one is hardware and performance related issues. MSD definitely helps to mitigate. If a controller is computing an SR path, and some of the nodes, if you are using Broadcom, it can support only 4 labels, for example. MSD will help you to mitigate this by choosing an alternate path. Controller can compute and PC initiated LSPs update the LSP on the ingress node. But if you don't have any other path, it's a problem. So that's where it helps here. And the other one is there are deployment scenarios where small packets are extremely the whole slices, for example. There are some slices where only the packet sizes are only 40 to 100 bytes. If you take into account the transport and network and path overhead, it's almost 300 to 400% overhead. So what is we are proposing? There is NSPF IDTL we are talking about. It's an empty capable prefix. Egress node advertises this. It could be any node. It advertises the FAC prefix, and also it advertises the ordered segment list. It could be NSPI, for example, NSPI IP type is MPLS. The ordered list is combination of segment or node adjacency or prefix sets. And there are a couple of other TLVs where that can be used for other purposes. I'll talk about it later.
Yeah. Did you really mean to do that, or?
No. So the computation, how do we do this? Once we advertise this, for example, this is an example, R1 to R4, it's an SR path. Once it is received of regular SPF computation for each topology, at the end of SPF computation, you just have to look into in the path NSP, if your router is in your path. If your router is in your path, your next hop is computed to the eventual destination. For example, R9, take the R9 case. R9, if R4 is the prefix it is advertising, the shortest path of prefix NH computed on SPF is R11. So instead, the next segment is R10, the next hop is changed to R10. So the same thing will happen on R8 and R1. So in summary, what we're talking about is a small change after SPF computation. Adjust your next hop to the next segment, next hop of the next segment instead of the eventual destination. That's all. After that, you have to program the data plane with the received NSPF ID. It could be MPLS prefix 8 or it could be SRH, IPv6 address SID to the next stop, corresponding next stop. And after this, all your local protections, FRRS, LFS, everything will work for the new next stop. So what's the relation with to binding SID? It's not related. There are earlier versions in SR, this is advertiser CROs. Binding SID is basically used for advertising the SIDs for on behalf of one node or multiple nodes, which are capable of SR or not. So there are two things we are thinking to update. I got some offline feedback on this. One is where to advertise this NSPs from. Today, SR, if PC initiated LSPs are programmed on the ingress node, you can advertise from the ingress node. But the thing is, your prefix is not from your ingress node. Your egress node is the owner of the prefix. So binding SID does differently. Any node can advertise the binding SID. But we were thinking if egress nodes, the owner of the prefix advertises this path, the advantage is Anycast is easy. We can solve this. Any node, we can give the flexibility. Any node can advertise this, but you need to put the system ID to disambiguate the Anycast prefixes. And the other TLVs I was talking about, the traffic accounting. You don't have to advertise the traffic accounting information in the IGPs. Your controller programs this and controller picks this up, the traffic information on all the nodes. Only thing is the NSPF ID will allow you to controller manage this traffic cleanly to the each path. Another thing is you can advertise, let's say I need this traffic accounting 1, 2. You can advertise along this NSP path. Let's say for out of my 10 paths, these 2 paths need my traffic accounting. It can be done. It's not visible properly.
Maybe we can zoom. Well,
okay,
you have choices.
So the same network I shown earlier, it has 8 SIDs. My RLD is 6. I have to introduce entropy labels at the right point. So it will be around 10 labels or 12 labels total. With NSPF ID, you just have all these label stack compressed into one label. So essentially what we are saying is you have the prefix, we have shortest path SID, and we are asking for another SID here. The SID is representation of all these ordered segment list from this is the top label to the last label. It is represented with this.
Mic use is really variable, I think, for the on the back.
Grab the mic and hold it with your hand.
Okay.
And then you'll always have
Make
in
it
front.
your own.
Yeah. Don't drop it after.
So the NSPF ID is the SID. In MPLS data plan, it's a prefix SID, or in SRH, it will be IPv6 address. This represents the ordered list of segments that is being pushed onto the ingress node.
I have one thing. You just said that you were going to change the optimization to have the egress control this.
Yeah.
But the binding SID isn't going to be owned by the egress. It's going to be owned by somebody else. Yeah, by everyone, right? Yeah.
No, I'm not talking about binding SIDs. Binding SID does that today.
Yes.
Any node can advertise the binding SID. You need not be owner of the prefix.
Right.
Binding SID can be done by any node.
But you said the owner of the prefix decides if it needs a non-shortest path.
I'm just saying that will allow you to not advertise system ID in the this thing in the TLV. If you put system ID of the TLV, you can any cache prefixes can be solved. Any node can advertise this.
Yes.
That's an option I'm asking.
Oh, right. Okay. An option. Okay. I mean, there's a disconnect between the egress and the guy that's on the path to the egress assigning a binding SID.
Today, PC initiated LSPs are programmed at the ingress node.
Oh, yeah.
Ingress node can advertise that, but you have to put a system ID to disambiguate any cache prefixes.
Yeah. Okay.
Can I put a few comments before you go? This is a good place to actually do a few comments. Andrew Dolgano. Okay. So, yes, there is a problem of too many labels. Great. I think we're misusing a little bit of terminology here. And this is not non-shortest path. You're still computing shortest path. You're just having different constraints that exclude certain links. Okay. You can do it that way at least. And then I'm a little bit concerned about us pushing into IGP signaling things that the routers can do by computations using different algorithms. or hardware should be able to do if it has proper label support or things like that. This can be solved by creating labels and like binding type of set labels, but pushing the where are we gonna draw the line? Because you could say you could do the same instead of binding sets with we can start advertising stuff, SPF in ISIS and come up with a solution for that. So once we make an exception, we may open a Pandora box.
So first I'll answer your first question. It is shortest path. The non-shortest path is each segment you'll compute the shortest path next hop. Overall, if you put all the labels, all the segments together, it is a non-shortest path. You are not changing any algorithm here.
Again, I would argue if you do computing shortest path, it just you excluding certain links that make you go around in whatever topology you're doing. And if I exclude the links if you go to the picture with links and exclude certain links through whatever, like something dictates you to take a path from A to B and omit the links that you're omitting from shortest path. So if you do this as a input to your shortest path calculation, that you de facto computing shortest path with a different links. This is no different than computing shortest path that has total redundant shortest path that has zero correlation between the primary. Yeah? You still computing shortest path, avoiding every link from the other path. And we don't signal that stuff. So why would we do the exception here? There is a real problem. I'm not arguing that there is a real problem. There is some technologies that avoid talking about how many labels we're adding. That's okay. That's also a problem.
So, Kiriti Kompella, you've just invented RSVPT all over again. You put an ERO inside of ISIS and you're sending it to everyone in the network instead of just going on the path you need to.
So I didn't invent anything RSVPTE. This is SR path. There's no TE. There's a TE there. This is SR path, and we are advertising to compress the labels.
Hi, Uma. I mean, this looks great when you have one of these, but if you are gonna use this, for example, for traffic engineering.
Put your name.
Cengiz Alaaddinoğlu packet design. Sorry. Actually, I just told my name this way. But in a tier 1 service provider, there's like 130,000 of these. 130,000 of these you're going to signal in your IGP.
No, you don't have to.
And they are changing dynamically as the links fail, come up, all of this stuff.
I'll tell you this. You have 4 labels. You have SR path has 4 labels. You don't have to advertise this. I have paths where my MST cannot help. And I cannot upgrade the routers.
I mean, I got that. Basically, there is.
You don't have to advertise all the paths.
Depth is a serious issue.
You advertise the SR paths which have problem.
But I think to address the scaling, you need to somehow limit how many of these you're gonna have, and then as the links fail and stuff, because this is an n-square computation theoretically, right? And how many of these is going to change, and then what does it mean for IGPs flooding? You have to basically address these issues if you want this to be operationally practical. In a single NSP, this looks beautiful, but it's not. We are talking about n-square problem here.
As I said, my only answer is you have a path where your hardware cannot support it. This can help you. You don't have to advertise. If you are happy with our labels and your hardware can support all 6 labels, 8 labels, you don't use it.
Hi, it's Peter from Cisco. So we had some sort of this same thing in the ISISSR draft originally, the ERO object and everything.
Yes.
Now we decided to remove it. Are we adding it back in this draft?
We're adding back. I don't know why you guys removed it. I don't know how to use it. I have a use case where this practically, actually, yesterday we have 2 hours discussion in DMM working group where this is useful. I'll tell that. I'll explain in the last slide actually. Okay. I don't know why did you remove it. So I have a use case here.
So it sounds like the answer is yes.
Okay. And the second question is, does the flex algo help in any way here, or do we need to signal and advertise it?
No, algorithm agnostic.
Okay.
So if you are using SPF, it's fine. You'd use SPF. if you have flex algorithm, you can use it. No
All
problem.
right.
No,
Thank
no,
you.
no, I can say there would be a way to solve it using flex algorithm.
Oh, there is a way. I would like to
mean-
see if you have anything.
I mean, you wouldn't be able to have the exact same path, but you could put it as a constraint
Yeah.
on the paths that you compute the MSD.
Sure.
Yes.
Yep.
Same thing for SRH. SRH, the problem is worst. We have 8 seats, 16 bytes. No hardware can, today I know I can do it. So the reason we were working on this, can you just zoom
Yeah,
out?
I was trying to zoom it.
Okay. So there is some of you had attended yesterday's DMM working group meeting. There is a 3GPP SI for N9 interface, the new interface for 5G, where they're looking for IETF technologies to include this for the data plane. SRv6 is one of the proponent there. I'm working with Dino on the Lisp. Lisp advantage of the Lisp is it solves the mobility plus it's agnostic to underlay. It doesn't propose that it will not put SRv6 or IPv6 on everybody. People, if you want SRv6, they can use it. And the advantage of Lisp is it is agnostic to underlay. It can be SRMPLS or SRIPv6. But the problem is there are slices, MMTC slice and URL slice. The short packets are there. All the data is constituted of short packets. So they cannot take this overhead. So this proposal can help in all the proposals for the yesterday's DMM working group.
Okay, so now we're talking SRv6. Okay, thank you. So because it's a lot of overhead and hardware doesn't support it, this is not a reason to hack IGP, and this is not the reason to say that not to use binding SIPs, and this is not the reason to say non-shortest path to something that is shortest path. Again, I can have a discussion offline. Okay. And for Kireri,
We're adding OSPF equivalent, and we got a lot of offline comments, and I take these comments.
And you'll continue this discussion on the list, right?
Absolutely.
So to our minute taker, do you think you captured all of that? Okay, thank you.
I'm sure.
Almost broke my keyboard.
I can meet you offline if you want.
Well, the next presenters come up. You know, if somebody really wants to, they can always listen to the recording. I've done that in the past.
Yes, and on that topic, I've JabberScribed typically 6 or 8 sessions per IETF. This is the worst with people wearing badges. So on Jabber here, you get the slides, you get a voice recording, and I'm typing down the name as you walk up to the mic. But if you're not wearing your badge and you're saying your name, well, even if you tell me your name, I'm going to get it wrong. So please wear your badge, and this will all be properly recorded, and the minute taker or whoever can get a good account of what went on here.
Right, and unlike your picture, it's not optional.
Yeah, I'm
You know-
sorry, Mike. I'll try to look closer to see that they're showing it to you. Okay. Now that we've been chastised. Black hole avoidance. Uma, did you do screen captures on ASCII text? Is that why we were having the problem? It's not.
Okay, good morning. This is Zhe Chen from Huawei, and the name of the draft is Avoiding Traffic Black Holes for Route Aggregation in ISS. And this is version 2 draft. And this is the change since version 0. We have added Dingcheng as a co-author. And in the previous draft, we extended the protocol and used a new ISS TLV to carry unreachable IP prefix. But in the latest draft, we introduced the infinite cost, such to reusing existing TLV instead of creating a new one. And this is the problem we are going to solve. And when ISS running in DC topology such as span leaf topology, the leaf nodes often configured to not to receive explicit routes from other leaf nodes. They only receive a default route and set the next hop to be out the spine node. So in this example, the traffic from leaf 1 to leaf 4 will be ECMP'd among all these span nodes. However, the link failure in the network will cause black holing problems. We use this example to illustrate this. If the link between span 3 and leaf 4 goes down, leaf 1 will not know it and still send traffic to span 3. So the traffic will be discarded at span 3, thus causing black holing problem. So this is the big picture of our solution. We also use this example to illustrate this. After the link failure, span 3 should advertise prefix A and prefix B to leaf 1, 2, and 3, and set the metric to be infinite. And after receiving the prefix, leaf 1 should add prefix A and prefix B to its routing table and set the next hop to be span 1 and span 2, thus avoiding the black holing. These are some details. When link failure happens between a span node and a leaf node, the span node should encode all prefix attached to the leaf node into the IP reachability TLV and set the cost of the prefix to be infinite. The value of infinite is still to be determined. And append the IP reachability TLV to the ISS RSP and send the RSP to every other leaf node it connects to. The leaf node should install each of the prefix into its routing table and set the next hop to be an ECIP group, including all span nodes it connects to except the one who advertised the prefix. So that's all. Any comments?
Les Ginsberg. So I think this was brought up a couple of IETFs ago. So I think I'm just repeating Naming's comment at the time, which is if you never learned the reachability from one of the leaf nodes, how do you advertise this sort of negative reachability?
I know that problem. I think this mechanism would work together with the naming's approach. And this approach is to make the recovery be quickly, and the naming's work can make it accuracy.
Andrew Dolgan on Nokia. I'm trying to understand what's the intent of the draft, telling people who know how to do protocols and advertisement how they should be doing this, showing one of the options. There are multiple options to solve your problem. This could be one of them. Doesn't need to be standardized. Anybody who does routing, advertisement, protocols probably knows how to do an advertisement when this happens, so you don't have blackhauling with existing mechanisms.
So just to follow up on the previous discussion, if you never learned the reachability from the leaf node, I don't see how you can decide to advertise
we can use
this infinite metric for something that you never learned in the first place.
Okay.
That's the point I'm trying to make.
Okay. After the link failure, we can use this mechanism to let the leaf node know the failure, and then we can use other mechanisms to get the accurate prefix. Okay.
There was an answer. There we go. So in any case, this is work building on top of spine leaf, right? I mean, it's related to the spine leaf work by naming.
Yeah.
Yeah. So why, if it's a good idea, then I think you guys should. It should not be done separately, right? I mean, I think you need to convince the naming, and you guys, if it's needed, put the work together.
Okay. Okay. Good suggestion.
I'm not. Les is looking at me very oddly. I'm not advocating for this to move forward. I'm just saying that why would it be separate?
Yeah, so always
If it
open.
doesn't make sense, then that also would keep it from becoming part of naming's work.
Right. And we're always open to discussion.
Yeah.
But the draft that Naming and I have co-authored has a different solution to this problem.
Okay, right. So I guess that's what I'm saying, right? Is that it?
Yeah.
And it covers a wider range of scenarios than this one.
So I think you need to address why their solution doesn't work. I mean, if you want to put forward a new one, Les is saying yours doesn't even work. But
It works, but it works with latency, we believe.
okay, well, let's do this on the list.
Okay.
Thank you.
Just a comment.
One comment.
I want to echo Lars' comments. If SPY 3 don't know all the reachability to those prefix attend to all the leaves, how could you allow SPY 3 to advertise the default route?
Okay. Thank you. Where are we? Approaching the end.
Or Waymo.
Flooding reduction. This one?
Yes.
I'm Huan Mochen from Huawei. Today I'm going to talk about OSPF and IS flooding reduction. So for large and dense network, so the IGB flooding will flood to every link, and for some link, multiple link state will flood into those links. So this will raise a lot of issues, such as reduced scalability and also slow down the convergence. I heard that for some big network, the convergence time may be seconds or 100 seconds. So here we propose a solution to resolve these issues through flooding to small portion of links. And also, we only flood LSA to link once, not multiple times. The solution consists of two parts. One part is we build flooding topology. The other part is some kind of revise the flooding procedure. A flooding topology, so for given entire topology within an area, a flooding topology is a sub-network. This sub-network
Keep the talking down, right? If I can hear up here, it's
this flooding topology connects every node in the network, but with much less links. So for the revised flooding procedure, so this procedure must satisfy that it must be backward compatible. Also, it must flood the link states to every node in any conditions, such as link down, node down, and link up. And also, we should or must reduce the flooding. The best case is almost minimized flooding. So we wanted to introduce more flooding. So I think that's the most of the requirement. Oh, it's too fast. So flooding, first we needed building a flooding topology. So there are many ways to build a flooding topology. So here I just present an example way to building a flooding topology. In fact, building flooding topology is simple. So here we can just give 3 steps to building a flooding topology. We maybe just need 2 steps. So first, we select a node in the network in some ways. For example, we can select the largest, the node with largest node ID as a root. And then each node in the network build a tree using this node as a root. And then we can build a tree very efficiently, maybe just in this time. So after we build a tree, and this tree, we can use this tree as a flooding topology. So if we want more redundancy, and then we can just add some connections, such as after we build a tree, and then we can connect the leaf on some branch of the tree, and then we have more redundancies. That's depends on you. So I think that after step 2, we have a flooding topology. So this just to give more details about building flooding topology. So for building a flooding topology, we can have two types of algorithms. So one type is that we don't consider which node is support or which node doesn't support flooding reduction. So this we assume that every node in network support flooding reduction. That's one type of algorithm. So another type is that we should consider whether a node supporting flooding reduction. So in order to have this type of algorithm, so we just introduce a 1-bit flag F, which indicates that whether a node supports flooding reduction. So if we set to 1, and then that means this node supports flooding reduction. So with this flag, and we can also consider the algorithm. So when we build the tree, we want those nodes supporting flooding reduction, maybe just connect together continuously, just achieve a better result. Of course, you can just ignore this kind of connecting those nodes supporting the flooding topology together. That's depending on you. Just this is only for the more efficiency.
Here, I'll get you there. Is that right?
Yeah, no, just those encoding.
Right.
So for this flag, we can just add 1 bit in the different protocols. In OSPF v2 is 1 bit. In OSPF v3 is also 1 bit in the router space. So in ISS, it's also a 1 bit. So this is in the different data structures is in the ISS router capability TLV at 1 bit. So this extension is very simple. And then let's look at the revised flooding procedure. So this procedure, the change is very simple. So we consider different case. One case is that for receiving a link state. So in this case, we just flood this LSA according to the flooding topology. For example, for this node A, node A receives a link state from node R1, and then node A will flood this LSA to the other link on the flooding topology. So in another special case, so node A may receive LSA from, for example, this node, and then this link is not on the flooding topology. So in this case, node A will flood this LSA to all the links on the flooding topology. So in this case, node A will flood this LSA to this one, and then to this one on the flooding topology, and then to this one on the flooding topology. So this is for the LSA, receiving LSA. So another case is that a node may originate LSA. So in this case, we divide into different subcases. One case is that this LSA without any change, just refresh. So in this case, we flood this LSA according to the flooding topology. So in another case is that this LSA with changes. So for example, this load is down, and then the LSA will generate this node will generate a LSA. So with changes. So in this case, we flood this LSA to every adjacencies. So this means that in simple term is that flooding in this case is according to the real topology. So it's simple.
So for LSAs that you're just flooding that somebody else originated, you always use the flooding topology you're saying, right?
Yes.
Okay.
So also we consider node up. So for example, in this case, a new node is up. In this case, we do some special considerations. So in this case, we assume only this node. Assume that this new adjacency is on the flooding topology. So that's all. So with this revised procedure, looks like we can cover all the cases, which means that in any case, we can guarantee the link state will flood into every node in the network according.
Wimo, I think you need to revise your fallback. You have the fallback. I believe the rule was if there's a link that's down, that's on the flooding topology, you flood all nodes.
Yes.
That won't do it alone. You need
only the local node, only the node. This node, the link connect to this node will do that one. So for
right. No, it won't work. If you have a flooding topology, this the triangle. Like if you have A to B to C, and then there's another A to C. If the link between B and C fails, B, if he floods on all his links, it still won't get it to C. You need a more elaborate rule on the fallback.
Yeah, okay.
You have to look at that.
Yeah. We'll consider more different cases because this is zero version, and then we try to cover all case. I know this is very complicated. We will consider more details and then cover.
Okay.
Curiti Compella. Even without the fallback, I'm not sure this works.
If you make your fallbacks,
forget the fallback.
Enough.
I mean, let's say you just had ABC, and A thinks its tree is ABC, and B thinks the tree is AC. A floods to B. B says
no. Wait, but I mean, to be
I'm
fair
going
here,
back.
I think that the topology is calculated at a
What?
central place. So
is it? It's not signaled.
No.
No, but there's not a unique tree. So he's flooding it. He's flooding the tree that he built. You're not flooding it.
Yeah, right.
There's a problem.
Right. I think for those cases, I think in those transition stage, I think we consider that one is not like seems no serious issues. I think we're for each case, if someone give a real scenario, and then we can dig out whether we cover that one. Yeah. I think also some people. So this is also some kind of mathematical problems, and then some people may be interested in, and then give some proof.
It's covered in the next presentation.
Yeah.
So the next presentation is
proof, whether this one cover everything. every case. Yes. This is a graphical serial problem.
Oh, let's take you to summary because I.
Okay, yeah. This is summary. Yeah, we presented the topology. So each node will generate the flooding topology. So we don't need this flooding topology to the network. And then I think those procedural solution we propose, I think we at the first shot we think we met this requirement. So we welcome comments.
My name is Xiaohu from Alibaba. I agree with AC's observation. It seems that it has and chicken issue. For instance, just as AC mentioned, if the link on the flooding topology changed, you need the dependency on the original flooding mechanism, right? In that case, the link down event had been flooded. Do you still need another flood on the reconverged flooding topology?
So regarding to link down, we just so people says that there's a real issue, chicken egg issue. So we maybe go through one real case to see whether we really have an issue. Okay. So for example, here we suppose this link is down. Okay. So in this case, this link is down. The procedure like this one. So node A will flood LC to everyone, to this one, to this one, to this one, to this one. So node R4 will do the same thing. So because node R4 will detect this link down, LC change, right? According to the revised procedure, this node will flood those changes LC to everyone, down, everyone. So in this case, where is the corner? Can you indicate where is the corner? So this LC change LC will flood to everyone, every nodes. Right?
If you want to reconvert the flooding topology, you need flood the link down information in the original flooding.
Yeah, that's right. So this link is down. So this node will generate the updated, let's say, right? So according to revised procedure, this node will flood this LC to everyone, to all the node adjacent to this node.
The problem is you flood it back to the guy that sent it. He's not going to reflood it to anybody.
Which one?
I mean, yeah, the guy who received it. You detect the failure, so it doesn't work in that case, at least.
So yeah. For some cases, because we need detailed version, so we just go through this topology to see whether it has a problem. I think for this topology, we don't see that problem, right?
Okay.
Okay, so we have topologies that don't work, and we're running out of time.
Yeah.
Okay.
So we find that don't work, and then we fix that.
Yeah, just a quick one. Andrew Dolgan, Nokia. You really need to do a better to justify this. These basic mechanisms you're trying to optimize, making them complex, aka making them wrong. And if you have flooding issue in that topology, then you change whoever software you're using. Because like this is a simple topology and people are poking issues in your solutions. So
yeah, no. As I said, this is we can have a theory, graphical theory, and then maybe we can prove that one. So we can say, oh, these have problem, these are problem. Give a concrete example, and then whether we can cover that one, right?
Stefan from Orange. I would tend to agree with Kiriti. This is a distributed system. Each router is computing the flooding topology by itself. How can you ensure that they are synchronized? While today we are not able to get them synchronized to solve microloops, for example.
Yeah, good question. So synchronize is in one sense, right?
Okay,
for example, in existing OSPF, every node use SPF. That is some kind of a synchronization, right?
No, but they are not running SPF at the same time.
Let's move on.
Yeah, so it's an interesting idea, and we've had some good comments.
I have one thing. I mean, there's there's a lot of ways that people are looking at this data center flooding problem, and we're obviously not going to standardize all of them. And so, it's going to be sort of a dependent on it. I think a lot of it's going to be dependent on implementations and what works, in simplicity. So,
Yes.
yeah, you can initiate more discussion on the list.
Thank you.
Thank you.
Tony.
I'm back. All right, so this talk is about how to do dynamic flooding, and this is inspired by looking at the data center routing problem yet again.
Yeah, I can do it for you.
Okay. That thing's touchy.
Yeah.
So we've seen this problem before. Long ago in a galaxy not so far away, we had a network built on top of frame relay. It only had 20 nodes. It had a full mesh of VCs, and it collapsed. And we scratched our heads and looked at it and played with it and said, oh, there's too much flooding. Now that was a full mesh network. And as soon as you have a full mesh, you've got tons and tons of flooding going on. And the solution that we had at the time was mesh groups. Okay, relatively straightforward.
How long did this slide take you to make?
This slide took me about 1 minute to make, because that little pretty picture you see there was courtesy of Google. I did not draw this. All right. So data center routing is actually a subset of this problem, and all of the techniques that we know about for solving the complete graph actually apply on the data center. You could use mesh groups in the data center except for one problem: configuration. That's unacceptable. Next slide. Okay, so if we're not going to do mesh groups, we're not going to do manual configuration, how about we just compute what links we want in our topology? Okay, reasonable, easy enough to do. Which system is going to do this configuration? Well, how about we elect one? Okay, well, that's not too hard. We've got DIS selection. We can apply the same thing at the area level and elect somebody at the area level to sit and do this computation, compute what the flooding topology should look like, and then flood that out. Next slide. Okay, so here's a really straightforward example. Suppose we've got a small data center, K20-200, 20 spines, 200 leaves. I'm told that's tiny compared to what many people are doing. That's 4,000 links. A flooding topology on that, we can just build a cycle doing round robin selection. Every leaf ends up with only 2 links on the flooding topology. We've got a cycle, so we have no problems with single points of failure. And so we end up flooding only on 20 links. 20 spines and then 400 links. So we've got a 90% reduction in our topology. Okay. What do we have to do for leader election? Well, it's very straightforward. We're just going to steal DIS selection completely, advertise one TLV into the area to indicate a preference, do election on all of those. Whoever wins the election, you don't have to signal anything. You just go ahead and do the computation.
Tony, can you back up once?
Yes, sir.
I mean, I see the 90% reduction, but you said 20 links. You mean 400 links?
The spines end up flooding on 20 links each.
Oh, right. Okay, yeah, right. Okay.
So one of the things you care about here is the diameter of the topology, and then the replication, the maximum degree of the node.
Okay.
Okay.
Yeah. I thought you meant the total flooding over the.
No.
Okay.
Sorry.
Yeah.
Okay. We can use the usual tiebreakers here. This seems relatively straightforward. Okay. So now, how do we flood the topology? How do we talk about what we're going to do? We need a reference mechanism for talking about the nodes in the topology, and unfortunately, can't think of a good way of absolutely describing everything that's going on. So, proposal here: let's flood a list of the systems in the area. And the list of the point of this is just to give us a set of indices to work with. If we have indices, then we can describe things very succinctly rather than carrying around a bunch of system IDs all over the place. And all of this is just to get the encoding down to something smaller. Okay. Now, in the initial version of this draft, I proposed sending out an adjacency matrix. My boss took one look at this. He mumbled some numbers and told me that I'm daft, to use the Britishism. He is absolutely right. This is a really bad way of doing things. I've withdrawn this and published another version of the draft where we do, next slide, a flooding path. If you use sparse matrix techniques and instead just list the indices of the systems that you want in your flooding topology, this actually turns out to require fewer bits on the wire by several orders of magnitude. So this is cheaper. So by just doing this, we can list all of the links that we need in the flooding topology. So this is reasonably efficient. Okay. Now, what is it we want in our flooding topology? Obviously, we need all of our nodes in the flooding topology. I think, and this is an opinion now, I think we want everything to be biconnected. Okay, no single points of failure. Not everybody agrees with that. You could do things that are higher connected, but of course, if you do that, you increase your amount of amplification that your flooding does. Probably want to think very hard about doing that. We want to minimize the node degree. We don't want one node that has to flood 12,000 copies of things if we don't have to. Really like to distribute the workload as much as possible. We want to minimize the diameter of the flooding topology. The diameter of the graph tells us how many times a link state update has to get forwarded before it's reached everybody in the entire topology. So we want to keep that down. Unfortunately, computing the topology itself is now a local computation. We actually don't have to standardize that. So I'm not going to tell you how to do it. You can do it whatever way you want. I'm offering a couple of suggestions here, but feel free to come up with something smarter. What's optimal for this? I don't know. There are lots of things in the graph theory literature. Folks can tell me what they want to do. Okay.
Your ISIS is showing.
Yes, it is.
They didn't standardize the SPF either.
I didn't write the OSPF yet. So next slide. Here's another example. This one I did write. This one took a long time to draw. It was a boring meeting. If anybody is from I did this in Keynote. If anybody from Apple is here, I want connectors. Connectors, please. Okay.
Omnigraph.
That would be okay.
So I think you can afford it.
This is K4. This is K417. It's got 68 links to begin with. Very, very small topology. If we look at the minimal topology, next slide, that alone drops it down to 34 links. So that's a 50% reduction already on a very tiny topology. And the savings go up just as you increase the replication. Okay. Now, I don't think I've ever seen anybody at IETF present a theorem before. That was said by the right person, too. All right. I define a minimal flooding topology on a spine leaf as biconnected with the degree of the leaf being 2. Okay, leaf only has 2 links throughout. I can show that for such a graph where the number of leaves becomes much larger than the number of spines, close to n squared, that there's a minimal flooding topology where the diameter is 4. This is a fun result because what this means is as we grow the topology, as we add racks, the flooding topology stays fast and if anything gets faster. So the diameter never goes above 4 if you get to a large enough size. So that's great, because it means that we're not going to have a scalability problem from a diameter perspective.
In the K, in the K, what are the N and M? That has to do with clause, right? Those are
No, spine. K is the notation for a complete bipartite graph, which is the graph theoretic words of saying leaf spine.
right. Okay, yeah.
Where it's got N spines and M leaves.
Okay. So
Okay.
it's just okay.
Yeah. All right. So basically, if we have a large enough topology, this algorithm performs pretty nicely. Okay. Now, another person brought up the fact that we're still flooding on too many links, and they were of the opinion that we didn't need to be biconnected. So what happens if we throw out the requirement for full biconnectivity? If you're feeling more risky and you don't care about losing the top of rack, you don't care about losing a leaf, well, what happens if we just keep our spines biconnected and make the leaves, some of the leaves, singly connected? Okay, well, we can reduce the topology even further. Next slide.
Can I ask you a question about the previous slide?
Sure.
You're saying that as the topology grows, this previous one to this, the problem is you want n squared leaves. And so the topology is not growing only in the leaves, it also is growing in the spine. And so the number of cases that you actually see this, I don't know data center networks, you probably know them better. But I don't think you actually get to n squared very often. I mean, it doesn't have to be a diameter of 4, and having a small diameter is good, but usually both will grow. And then I'm not sure that
Well,
you get this.
it is a ratio, right?
Yeah,
and as yes, agreed, if this number of spines is going to grow very quickly, then you're going to have problems.
You'll have a bigger diameter.
Right. You also, if you're going to end up growing a lot, you're going to end up probably going to a deeper topology where you're not just strict leaf spine, but you're going to have but everything gets more interesting when you do that. So I did not look into that. Okay, it could. Okay, moving on. Oops. So if you take that and you're willing to take risk, and you can see you end up with a bunch of leaves that are singly connected here, you can cut the topology even further. You're down to 21 links. Okay. All right. A little bit of wisdom from dealing with scalability problems for my entire career. Whenever we have these problems, we should use all available tools. Any one tool is only going to give you so much. And if we don't use all available tools, we end up with a mess because we really haven't attacked and made enough for progress on the scalability problem. This is just one more tool in the tool chest. This solution is nice because it is really strictly not for data centers, but it's for any dense topology. We designed link state protocols in the flooding back when links were really expensive. 64 kilobit synchronous modems and imps, and that cost millions of dollars, and we no longer have that problem. Now a link is $5.99 at Fry's. It's just not worth it. So we really have a different design point than where we started building link state protocols. It's not surprising that flooding doesn't work. And this is another approach for rethinking how to do things in the general case where we've got dense topologies. This solution is nice because we don't care about lateral links. You can add whatever you like to your topology. If you decide you have to have a link between two racks, well, this will adapt. External links are not a problem if you want to interact and expand your area outside of your data center. This works. We can also combine this with some of the other proposals. Naming and Les have a nice draft. If you apply that too, you have some restrictions, but you can get even better scaling because you're flooding less information. So, all right. Last, if you like this, If you like this, please seek out this lady. Her name's Artie. Tell her you like it. All right. Thank you. Any questions?
Just one question. You have listed benefits for reducing the flooding. What's the drawback?
What's the drawbacks?
Yeah.
Pretty much the only drawback that I see is that we're going to add to the link state database. We're actually adding more information that has to be flooded around. So if you take a look and say, well, we're decreasing a multiplier on this side of the equation, but we're adding to the value on this side of the equation, right? So it's a trade-off.
Yeah. Right? I heard that a major motivation for doing BGP, SPF, and Rift is to achieve fast convergence. Will Approach slow down the convergence or fasten the convergence?
So this, well, considering what the alternative is collapse, this is faster convergence than collapsing.
No. In a spine leaf, he said the maximum diameter of the flooding was 4 because you have to go up and down.
No. Only if you get n squared leaves for n spine.
Okay, well, yeah, that's
So I mean, it could be faster though, right? I mean, it also could be faster because if you're processing a huge amount of redundant,
right? If you're
flooded LSAs or LFPs,
if you're doing 64-way ECMP and you're looping through them all, yeah.
Yeah. If you're, it's always complicated.
You need the list of, I mean, after you get your mapping, and I'm not sure how you do the mapping of sys IDs to numbers in some nice way. You need the list of whatever the flooding topology, which I don't know how you fit that in ISIS.
So let's back up. So the list is just,
You just passed
the
it.
order. No, this is perfect.
Oh, this one, yeah.
Okay, this is the list, and the index, you're just flooding the list of system IDs in the area.
Yeah.
And the ordering of the list tells you what the index is.
Okay.
Okay. So now, next slide. There. So now this says, okay, we have a link from system at index 0 to system at index 2, another link from 2 to 1, another link from 1 to 3, another link from 3 to 0, right?
But if you have 255 or 256 things in a path,
well,
ISIS
you can, this is one TLV.
okay.
Hey, Les, maybe you'll finally get to see your 16-bit length TLVs get used.
Yeah, we can go with ISIS V2.
I haven't been used yet.
So I like this, and this is sort of the comment on the difference between you've laid out the architecture. If you want to write a complete draft, we have to handle the transition cases. Do you want to talk about that at all?
So the transition cases I don't think are problematic. This is because the worst problem that you have is that you have an old topology and a new topology, both are being flooded at the same time. If that does happen, you don't have to decide, you just flood on both. And they're very likely to overlap significantly, so you're not having a real bad time anyway. Also, the other transition that's going to happen is if you actually lose, wrong answer. Hang on.
No.
So actually, I have a question about what you said. Does it mean you flood on the union of the two?
Correct.
Yeah.
Well, I mean, one of the things that could happen, right, is the designated
Area leader is the word.
area leader. Okay, thank you. Yeah, he's the one who has some sort of failure, and so then you're transitioning to a new area leader, and since you're not standardizing the algorithm, you end up with a different flooding topology, but you've got the transition of how do I make sure nothing's lost in that transition.
Right. So one of the things that would make sense, okay, first when the area leader dies, we have to note that we're going to have to first lose those adjacencies and flood all of that on the flooding topology that the area leader first advertised. Okay, so the network converges quickly even if you lose the area leader. Now,
Right.
when you elect a new area leader, assuming the first area leader doesn't come up quickly, then you're going to want to have that new area leader flood a new topology. And a smart thing that he might want to do, and this is more risky, but he might want to purge the original area leader's topology. In the overlap, we have this dangerous transition where you might have to flood on both topologies. Okay.
I have one before Alvaro makes a question. When let's say you have bi-connected, are you accepting the fact the area leader doesn't go down, but you have some information that is flooded in between computations of topologies? How do you assure that's reliable if you lose your flooding topology if somebody's completely isolated?
If there are two topology changes so that the original flooding topology is
Like say
no
a
longer
spine is isolated, it loses it has
then it's up to the area leader to recompute.
And he does recompute. What about changes in the interim? How do you make sure those, because he's bringing up new adjacencies.
So he wants to
He'll bring up new adjacencies, so then he'll synchronize and everything will be right. Okay.
He wants to reflood as often as he can. Obviously, you want to rate limit it so that he's not thrashing the world.
Yes, right.
But he wants to respond to every topology change on the flooding topology.
Yes.
Hi, Alvaro Rutana, Huawei, speaking as a working group member. So I don't have a specific comment about your solution, but what I want to say is that most of the questions that have come up are around what happens if this fails, what happens if that node fails, what happens when the link goes up, even for Feynman's presentation before. As Tony said, this is not a new problem, right? This is an old problem, and it has been solved before for link state protocols as well. If you recall, 10 years ago, we had years of discussion here in this working group, or in the OSPF working group, the non-existent OSPF working group, about how to optimize flooding in link state protocols. And in fact, we ended up with three RFCs, three experimental RFCs. Now, I realized that the context of that was in mobile networks. Now, mobile networks have failures all the time, right? You're moving all the time. You never know where the leader is. You never know if the link is going to go down, 1 second from now. You never know what happens once you transmit the LSA, if it actually got to the other side or not. But the mechanisms that have been done not only are implemented for SPF, but most importantly for OLSR, which is deployed, and it works pretty well. The mechanism, you can go read all about OLSR. I think one of the RCs here was 5820 or something that I remember. And basically the mechanism, the difference is that it's a very distributed calculation where each node, as you transmit, you decide which is the optimal way to get somewhere. And so at every hop, if things fail in the transit, then every hop sort of helps fix the topology. So I think, nice work. I think personally, it's probably too complicated, and not to throw more wrenches into this thing, but there's other solutions as well that we should probably take a look at.
Cengiz Alaaddinoğlu, I'll spell it for you.
Where's the
It's in the
badge?
room, so I'm not gonna.
Oh.
Again, it's more of a follow-up to what AC said, and I think you answered it, but I just wanna double check. It's more of a clarification. So when the flooding topology changes and a new link becomes part of the flooding topology, those two routers send CSMPs of some sort to synchronize what they know about what has been flooded while the topology was changing.
So I didn't say too much about CSNPs, but I think you want to be sending CSNPs as you would normally on all links.
I mean,
right?
it's a point-to-point
Steady state.
thing, right? So it's a point-to-point thing. You don't really send CSMPs, but you have to send it in this case.
I think you should.
Yeah, I think normally we do send them anyway to be safe.
Usually in the broadcast, you send.
You're not doing
point-to-point,
that
you don't.
anymore? You, I don't know.
But I think you should.
I did. That's why I said you, because you're working on it now.
Curity. I like the idea in general, but the idea of sending out having one person, area leader decide what the flooding topology is good and bad. It's good because, you don't have these problems. I think in the previous presentation, there was a big flaw. On the other hand, if you could have everyone deterministically compute the same thing, then you wouldn't have to actually send it out. And that might be better and might be more robust, because if someone along the flooding topology realizes there's been a flooding change, topology change because some link went down or some node went down, they can adapt to it. But yeah,
I agree completely. And the problem that I ran into is, how do we agree on what topology to compute?
Yeah, I know. But we have to set you higher goals.
I mean, I think this what
work harder.
Yeah. What Tony's proposed works much better in fairly stable, very dense topologies.
And as you know, I would rather ship something that works rather than worrying about doing this perfect thing.
One other comment, Kiriti, again, is if something along the flooding topology breaks and you fall back, and I mean, we haven't discussed it, I haven't seen it, but if you fall back to flooding on everything because you're just not sure about things, that'd be really bad, because you get into the problem that you're trying to solve.
Right. So the algorithm here, again, is not that you fall back to universal flooding. Okay. If something breaks on the flooding topology, you first flood the update about the flooding topology on the flooding topology. And because it's bi-connected, it's still connected, right? So your update gets all the way around. Everybody gets that. And now it's up to the area leader to recompute what we want to do, because we're now vulnerable. We're no longer bi-connected.
Okay.
And at least I'm happy for now. I got to think about this more.
Yeah, me too.
If there's somebody who is completely isolated, and the new flooding topology will bring up an adjacency, and then he'll start from scratch, and he'll synchronize, and he'll converge. I mean, it'll be a little. If you lose bi-connectivity, you accept a little bit longer delay in, reconverging.
Okay. The idea where you had all these spines that were single connected scares the shit out of me.
Scares the shit out of me too, but I'm not the guy running the network. If customers want that, I'm fine with it. For me, it's just another topology. Next step for this, I'd like to ask for working group adoption.
Yeah, I think that so the authors requested working group adoption. I think it's a wee bit early, but we can discuss this on the list. We can put that out on the list.
Yeah. One problem. I read the first version, but I have not read the updated version yet.
Thanks everybody, and I think we'll see you in Montreal if you can make it.
Let me see if I can find the blue sheets.
Did everybody sign the blue sheets?
Please sign the blue sheets, or the room will shrink again. Here.